carbon cycle and global warming. Carbon is present in every living organism, our atmosphere, oceans, and Earth. It's all around us and constantly circulating, being absorbed and released in cycles that have been taking place since the beginning of the Earth. The carbon cycle is the flow of carbon in and between four areas of our planet. The first area we'll discuss is the terrestrial biosphere. The terrestrial biosphere includes all living organisms such as plants and animals that live outside of the oceans. The atmosphere is the layer of gases that surrounds the Earth, what we typically refer to as air. The oceans include all of the water and living organisms and non-living substances within. The geosphere includes all of the land, sediments such as oil deposits and rock. Let's first take a look at a very simple carbon cycle within the terrestrial biosphere and atmosphere. Suppose we have a single animal, Kate the cow, living in a glass bubble. Our friend Kate the cow enjoys eating plants. Plants, like all living organisms, contain carbon. As Kate eats, she absorbs carbon from the plants into her body. Some of that carbon is used to increase the mass of her body. Some Kate exhales as carbon dioxide into the atmosphere. If nobody were around to absorb the carbon dioxide from the atmosphere, Kate would find herself in an environment with too much carbon dioxide. Well, that's where Pat the plant comes in. As Pat basks in the sun, his leaves absorb carbon dioxide from the air. Pat converts the carbon into plant material in order to grow, effectively storing the carbon in his leaves and stem. So you can see, all living organisms, including plants and animals, store carbon in their bodies. When Kate cruises over and eats the plant, she absorbs the carbon from the plant and the process continues. This simple cycle illustrates how carbon moves within the biosphere from Pat to Kate. It also illustrates how carbon travels between the biosphere and atmosphere, as Kate releases carbon dioxide and Pat absorbs carbon dioxide. As you might imagine, the carbon cycle on our Earth is much more complex than this simple example. Let's first take a look at our terrestrial biosphere to better understand some processes in the carbon cycle. Inside an animal's body, carbon from nutrients and food is consumed, and carbon dioxide is released as waste. This process, called respiration, causes a flow of carbon from the biosphere to the atmosphere. Even fungi and bacteria play a role in the transfer of carbon. As our friend Kate drops cow patties in her pasture, fungi and bacteria break down the manure into methane and carbon dioxide. The total amount of carbon-containing gases generated by decaying cow manure is huge. A similar process occurs when an animal dies. Bacteria and fungi convert much of the carbon in its body into carbon dioxide or methane. Over long periods of time, dead organic matter can petrify or turn into stone and become a part of the geosphere. This process, called sedimentation, is also what produces fossil fuels such as oil. Plants play a major role in the carbon cycle by using the sun's energy to absorb carbon dioxide from the atmosphere and convert it into sugars in order to grow, essentially storing the carbon in their leaves and stalks or trunks. Photosynthesis causes an overall flow of carbon dioxide from the atmosphere into the biosphere. When you burn plant material, such as a log, the burning releases carbon stored in the log as carbon dioxide. This process of burning biomass causes an overall flow of carbon from the biosphere into the atmosphere. Now let's take a look at our oceans. Algae include tiny organisms living near the surface of the ocean and giant kelp growing far below. Algae perform photosynthesis, and in doing so absorb carbon dioxide dissolved in the surrounding water. There's a huge amount of algae in our oceans, and it plays a significant role in the carbon cycle. What happens to carbon stored in the algae? Let's suppose some plankton swim by and eat the algae. Now a fish eats the plankton. Thus, the carbon eventually ends up in the fish. Like animals in the terrestrial biosphere, fish release carbon dioxide through their gills as they respirate. When a fish eventually dies, it decays and much of its carbon is released back into the ocean. Carbon enters the oceans from the geosphere in a form called bicarbonate. Bicarbonate is produced when certain types of rocks, called silicate rocks, weather. Some of this bicarbonate eventually flows into the oceans. Bicarbonate also forms in ocean water as carbon dioxide in the atmosphere reacts with water molecules. The bicarbonate in ocean water plays many roles. Many types of organisms within the ocean use bicarbonate in the water to build their structures, such as shells. Some of the bicarbonate in the oceans combines with other substances present in the water to form limestone. The limestone sinks to the bottom of the ocean, locking up the carbon in the geosphere for a very long period of time. A great deal of bicarbonate remains and allows the ocean water itself to act as a giant carbon reservoir. The amount of carbon that the ocean can hold depends on its temperature. At low water temperatures, the ocean can absorb more carbon, while at higher temperatures it can hold less carbon. As ocean water flows between the cold poles and equator, and as it cycles to and from the warm shallows and cold depths, it absorbs and releases carbon from the atmosphere, typically as carbon dioxide. The geosphere also plays a major role in the carbon cycle. Several processes move carbon from the geosphere to the atmosphere. Volcanic eruptions release carbon dioxide from molten rock beneath the Earth's surface. The production of cement that's used for homes, skyscrapers, streets, and other hardscapes around the world releases an enormous amount of carbon dioxide. You see, cement is made from limestone taken from the geosphere. Cement production involves heating limestone and releasing its stored carbon as carbon dioxide. Burning fossil fuels like gasoline, diesel, and coal releases carbon into the atmosphere. Every time you drive your gas car, you are burning carbon that was stored underground for millions of years. As you can see, the flow of carbon within our planet is amazingly complex, and we're only taking a look at a tiny part of it. What's unfortunate is that recent scientific evidence indicates that humans have upset the carbon cycle, leaving more carbon dioxide and other greenhouse gases in the atmosphere. Burning fossil fuels such as oil and natural gas, burning biomass such as ethanol and wood, creating cement, and releasing other chemicals into the atmosphere is upsetting the natural flow of carbon. Greenhouse gases in our atmosphere act almost like a blanket between the Earth and frigid space. At lower levels, greenhouse gases trap some heat in our atmosphere while letting other heat radiate out into space. However, as the layer of greenhouse gases around our planet grows thicker, more heat is trapped in our atmosphere, less radiates away, and the Earth slowly heats up. Hopefully you now understand how complex the flow of carbon is on our planet, and how we as humans are currently impacting its natural cycles.